guys. Okay, so lesson 2 from home. So hopefully we all did right with empirical formula. Today we're going to move on to molecular formula. Now, just so you know, in order to determine the molecular formula of something, you first need the empirical formula. Okay, so firstly, the formal definition, excuse the bell, my cat's playing. The formal definition, molecular formula, is the formula of a compound that shows the number of atoms of each element. So if you remember back to yesterday, to the empirical formula, that shows you the ratios of the elements involved, but it doesn't actually tell you how many atoms you have of each. So now, when you know the ratios of each, you can then determine the actual number of atoms of each, but you need one piece of information. You need to know the molar mass of your actual compound. So if you know two things, if you have the empirical formula, okay, and you also have the actual molar mass of your compound. If you have these two things, these two are needed, and if you have them, then you can determine the molecular formula of your compound. Okay, so just quick, the way we're going to go ahead and do it, you need to first, when you've determined the empirical formula, if you can figure out the molar mass of what you have, and you compare it to the molar mass of your actual chemical compound, you can see, well, how much too little do I have compared to what I ought to have? Okay, so we're looking, how much too little do I have compared to what I'm supposed to have? So in order to do that, you need to find out the factor by which yours is too small. Okay, so you need to figure out, well, compared to what I should have, how much too little do I have? Oh my word, it's not going well. Sorry about that. Okay, so our factor here, the way we determine that, is we take the molar mass of the actual compound. Okay, so the actual molar mass of our compound, and we divide that by the molar mass of our empirical formula. Okay, so I'm just going to use the shorthand here, EF, for empirical formula. So we take the molar mass of our compound, divide that by the molar mass of our empirical formula, and that gives us the factor by which we are too small. When you have that, then whatever your empirical formula is, so let's say our empirical formula is x, a, y, b. Let's say we have two elements, x and y, and the ratio of a to b. Then we just take the a and the b and multiply both of those by our factor. Okay, so I'm going to pause you there while I write down an example that we're going to do together. Okay guys, so here's our example. They've told us that the empirical formula of a compound that has mass 283.89 grams per mole is P2O5, and we need to determine the molecular formula. So, three very important things here. First off, what are they asking? They're asking for the molecular formula. And then secondly, they've actually given us two pieces of information here. They've given us the molar mass of the actual compound, and they've given us the empirical formula of the compound. Okay, now very important, if ever they do not give you in the question the empirical formula, you have to first figure that one out. So that's what we did yesterday. So you first have to figure out the empirical formula using the table, if it isn't given to you, and then find the molecular formula. Okay, so just going to write a little note on that. If empirical formula is not given, okay, then we first have to determine this, and that's using the table that we did yesterday. Luckily, here they have actually given it to us, so we do not have to determine it ourselves. Okay, so we can go straight into answering the question. Now, in order to determine the factor by which we need to multiply these, so remember our factor is equal to the molar mass of the actual compound divided by the molar mass of your empirical formula. So we know the molar mass of the actual compound. We do not know the molar mass of the empirical formula. We need to figure that out. Not hard to do. We did do that at school on Monday for those of you that were there. We did also do it last year, so you should be happy with finding the molar mass. So the molar mass for our empirical formula is just equal to the atomic masses of your periodic table of each atom in our compound. So in our empirical formula, we have 2 phosphorus atoms and 5 oxygen atoms. So that's going to be, and now I'm using a different periodic table to you again. I'm sorry, your numbers might be slightly different. But for phosphorus, I've got 31. And for oxygen, I've got 16. And when we work out the molar mass of that, what are we going to have? 62 plus 5 times 16. So we get 142 as the molar mass of our empirical formula. So now we can take this information and put it into this formula. So we're going to have our factor equal to the actual molar mass, there it is in the question, 283,89 divided by the molar mass of our empirical formula, which is 142. And when we do that, we should get roughly 2. It looks like 2 to me. 283.89 divided by 142. We get 1,999. Okay, so we can say that's good enough. That is 2. So now what we do with this factor is we're going to take that factor and multiply our bonding ratios in our empirical formula by that factor. So I had P2O5. I need to multiply those by 2, so I'm going to have P4O10 as my molecular formula for this substance. Okay, so that's example 1. I'm now going to do the second example with you. Okay, so here's example 2. We've got a compound with an empirical formula of C2H4. So that's important. Empirical formula is C2H4. And it is found that the molar mass of the compound is 28 grams per mole. So there's also our other piece of important information. And we need to determine the molecular formula. That is what we're looking for. So we know when we find molecular formula, we need 2 things. We need the molar mass of the actual compound, we've got it, and we need the molar mass of our empirical formula, there it is. So let's jump straight into determining that. We need the molar mass of C2H4, which is 2 times the atomic mass of carbon plus 4 times the atomic mass of hydrogen, and we get 28 grams per mole. Okay, which is actually the same as this thing's actual molar mass, which means that we do not have any less than we need to have. We have the right number of atoms present, which actually tells us that in this case, the molecular formula is the same thing as the empirical formula. Okay, it's the same for this case. So that means that our empirical formula is in fact, well, our molecular formula rather, sorry, is in fact C2H4. Same thing as our empirical formula. Okay, that's it for today. I will send you the worksheet. It is already on OneDrive. I will forward it to WhatsApp for you. Let me know if you get stuck, please.